letter B. We will do the same thing for letter B. So B, 1 mole nickel, convert this to atoms. So 1 mole nickel times 6.022 times 10 to the 23rd nickel atoms per 1 mole nickel. Then you cancel out the mole. Then you have 6.02 times 10 to the 23rd nickel atoms. Okay. Then you convert 1 mole nickel to grams. So what is the molar mass of nickel? Okay, so times 58.6934 grams nickel per 1 mole nickel. And then you cancel that, the number of moles. Then you'll be left with 58.6934 grams nickel. Okay, and then for letter C, no questions in that. Letter C, 1 mole bromine. So the same, 1 mole bromine times 6.022 times 10 to the 23rd bromine atoms per 1 mole bromine. So this is just equal to 6.022 times 10 to the 23rd bromine atoms. And now we convert mole bromine to grams. So 1 mole bromine, what is the molar mass of bromine? 79.904 grams bromine per 1 mole bromine. Make sure you cancel out the mole unit. Then that means that 1 mole bromine is just equal to 79.904 grams bromine. Then for letter D, okay, letter D, we have 1 mole gold. Au is gold, right? So 1 mole Au times 6.022 times 10 to the 23rd Au atoms per 1 mole Au. Then mole unit cancels out. Then this is just 6.022 times 10 to the 23rd gold atoms. Then now we convert 1 mole Au to grams. So what is the molar mass of Au? Okay, 196.9665. 55. Okay, grams Au per 1 mole Au. And this cancels out. So this is just 196.9655 grams Au. Okay. No questions for number 1? You multiply it by 2. Yes. Okay. All right. Okay. So let's move on to number 2. Number 2. For each, calculate the mass in grams. So we're given here 15 billion. That's a lot. Carbon atoms. So carbon atoms, you convert this to mole and then we convert to mass. All right? Because we are asked for the mass. Grams. So we start with 15 billion. So 15 billion carbon atoms times 1 mole carbon per 6.022 times 10 to the 23rd carbon atoms. So we convert atoms to mole first. Are you allowed to use the calculator? Alright, so 5 billion divided by 6.022 times 10 to the 20th. 15, not 14. Because you can write that 15, 1.5. I got 2.49 times 10 to the negative 14 mole carbon. Okay. And then we convert that to grams. So from make sure you cancel out the unit atoms, right? So you can get the unit mole of carbons. That's why you divide 15 billion carbon atoms by 6.022 times 10 to the 23rd. And you got the answer correctly. So that is 2.49 times 10 to the negative 14. And now we are asked for the grams. So we need to convert a number of moles to grams. So 2.49 times 10 to the negative 14 moles carbon. What is the molar mass of carbon? 12.01. Okay, 12.01 grams carbon per 1 mole carbon. So that means you multiply this one. You multiply 2.49 times 10 to the negative 14 mole by 12.01. So what's your answer? I got 2.99 times 10 to the negative 13. You should do it again. Maybe you made a mistake typing in your calculator. Because your phone is too narrow. If you use an iPad for the live board, then it would be a landscape. Then you can see it. You can clearly see it. Okay, because you need to cancel out the unit of mole. It's supposed to be like this: times grams over mole, like that. And then you cancel mole, then you'll be left with the gram unit. But at least you got the correct answer. It's 2.99 times 10 to the negative 13 grams. All right, so let's move on to letter B. No questions on this? Okay. So let's move on to letter B. B, we're given 0.0010 mole carbon. Still carbon, and then we convert this to grams. So this one, since we're given the number of moles, we don't need to use the Avogadro's number. So we just do directly. 0.010 mole carbon times the molar mass of carbon, that is 12.01 grams carbon per 1 mole carbon. And then this cancels out. So what is 0.010 times 12.01? Okay, so that should be the answer. Okay, no questions on this. We move on to number 3. All right. Okay. Number 3. So we're given CH3COOH. We need to find the molar mass for each of this one, the compounds, in 3 significant figures. Okay. So this is what we're going to do. we put all of each of the elements together. So we have two carbons, right? For carbon atoms, we have two here. So there will be 2 times the molar mass of carbon. So 2 times 12.01 grams per mole, right? So 2 times 12.01 grams per mole. And then for hydrogen, we have 4 hydrogens there, right? So 4 times, what's the molar mass of hydrogen? 1.01. Okay, 0.1 grams per mole. That one. And then for oxygen, we have 2 oxygens there. So you multiply by 2. 2 times, oxygen is 16.0 grams per mole. Okay, so let's calculate that. 12.01 times 2. That is 24.02 grams per mole. Did you get the same? 1.001 times 4. So this is 4.004 grams per mole. And then 16, that is 32. 32 grams per mole. So you add up everything, then you can get the molar mass of. So molar mass of CH3COOH is equal to 24.02 grams per mole plus 4.004 grams per mole plus 32 grams per mole. So the total of this is the molar mass of the whole compound. So that is 60.024 or 0.5024 grams per mole. Yes, because it's asking for molar mass. Yeah. So 2 times 55. Wow, that's 84 or 55.85. Then plus oxygen is 3 times 16. So this is 111.70 plus 48. What did you get? Okay. Okay, that's correct. Which one? Letter C? Oh, yeah. Okay, so we're asked to report for 3 significant digits. Yeah, that one is 160. Then we have CH2Cl2. Okay. One 1.01. So that is 12.01 plus. What is the? Okay, 35.453. So that is 12.01 plus 2.016, right? 101 plus 1.008 plus 70.90. What did you get? I got Yeah, the same. I got 84.93. And yeah, grams per mole. Then next one is NH4. NH42SO4. Is this ammonium sulfate? Do you know how to read compounds? Not yet. To name compounds. Yes, and SO4 is sulfate. BM. Alright, so molar mass of this, we have 2 atoms of nitrogen. So what's the molar mass of nitrogen? 2 times 14 plus. Then hydrogen is 8, right? You have 8 atoms of hydrogen there. Plus 8 times 1.001 or 1.01. Then for sulfur, you have 1 times 32. Is it 32? Okay, and then for oxygen, you have 4 times 16. Okay. All right, so it's the same. 132 point, I got 132.14 grams per mole. But 3 significant figures, so you can just round this off to approximately 132 grams per mole. This, we move on to number 4. So number 4, complete the following for each compound listed. So for letter A, we convert mole, 1 mole SO3. What is SO3? What's that? Sulfite? Okay, you convert this to molecules. To convert this to molecules, we use the Avogadro's number. Yeah. Yeah. Because we need to convert that to molecules. So we need the Avogadro's number. So 1 mole SO3, we multiply this by 6.022 times 10 to the 23rd molecules SO3 per 1 mole SO3. So whenever you're given, whenever you are asked to convert moles to molecules, atoms, ions, you use the Avogadro's number. Okay. So 1 mole is 6.022 times 10 to the 23rd molecules. Yes. If you're going to convert it to molecules, atoms, ions. And then the next one is you convert 1 mole SO3 to grams. So what is the molar mass of SO3? 16 plus sulfur. Okay, so that is 80.07 grams SO3. So that is the value of 1 mole of SO3. Okay, the next one is MgCl2. Formula units, that means you use the Avogadro's number again. So 1 mole MgCl2 times 6.06 6.022 times 10 to the 23rd formula units of MgCl2 per 1 mole MgCl2. Then the mole unit cancels out, so this is just 6.022 times 10 to the 23rd formula units of MgCl2. And now we need to convert the 1 mole to grams. So 1 mole MgCl2 times, what is the molar mass of MgCl2? Okay, the whole thing, magnesium and chlorine, 95.111, 95.21. Okay, so what is the answer? The answer is 95.21 because it's only 1 mole. All right. Then for the next one, 1 mole PCl5. PCl5. So we're asked to convert mole to molecules, the same thing. PCl5. So you multiply by the Avogadro's number. Molecules per 1 mole PCl5. So this is just 6.022 times 10 to the 23rd molecules PCl5. And then we convert mole to grams. What is the molar mass of PCl5? Okay, so that is the grams, the mass of PCl5 in 1 mole. Okay, no questions? Let's move on to number 5. 1 to 4, it's just easy. For each of the following, determine the mass needed to supply the quantity indicated. So we're given here for the first one, 2.51 mole CCl4. So how do you read CCl4? Yeah, you're right. So carbon tetrachloride. So we need to convert 2.5 moles of carbon tetrachloride mass. So we get the mass for 2.51 mole CCl4. So we start with that. So 2.51 mole CCl4, we multiply this by the molar mass of CCl4. What is the molar mass of CCl4? Yeah. So 153.8227. Then you multiply that by 2.51. Yes. Yes. No, you multiply it by 1 mole. So you can cancel this one. Cancel the mole unit of CCl4. Then you'll be left with grams. It should be, because we are interested in grams. Mm-hmm. Okay, you will multiply this, so the smallest number of significant figures is 3. Yeah. So for the rules in what's this? In multiplying, you still remember? So it should be 3 significant figures. So you got 386.1. Okay, 386.1 or 386 grams. Then for the next one, you convert 0.987 mole of, what is an ABr? Okay, so P is 0.987 mole. That is mole, right? Mole and ABR. And then you convert that to grams. Mm-hmm. 102. Okay. So that's the molar mass of sodium bromide. Yeah, and then you multiply that by 0.987. Yeah, 101.5. So 101.5 grams NABR. Because we have three significant figures here from the 0.987. Yeah. And then the next, yes, you can write that to approximately 102 grams. And then for the next one, 27 billion water molecules. How do you convert that? 27 billion. Okay, you can write that in scientific notation first. So 27 billion water molecules. Notice here that we're given molecules. We convert this to grams. So that means we convert molecules to mole first. So that is 27 billion molecules times 1 mole. 1 mole, this is water, H2O. 1 mole more water per 6.022 times 10 to the 23rd molecules water. So that's how to convert that to moles. To cancel out the molecules unit here. So what is 27 billion divided by 6.022? 27 billion can be written as 27 times 10 to the 9, right? Okay, so that's correct. So you already got the number of moles of water. But it says we need to convert this to grams. Determine the mass needed to supply the quantity. So we convert that to grams. We start from the number of moles. That is 4.48 times 10 to the negative 14 moles water times the molar mass of water. Okay, so 18.01528. So maybe 18.02. So what is the answer here? 4.48 times 10 to the negative 14 times 18. So the mole unit should cancel out and you should be left with grams only. Or, oh, I got 8.07 times 10 to the negative 13 grams. You check if you got the same answer. 4.48 times. Oh, you don't need the 6.022 anymore because we already got the number of moles. Yes, because we already did that. So you start with the number of moles, which is 4.48 times 10 to the negative 14. This one. Can you see my writings here? This one, the one that I am underlined. Okay, you multiply that by 18.02. Then that would be your final answer. I got 8.07 times 10 to the negative 13 grams water. Did you get the same thing? Okay. All right. Okay, no questions on this? You understood everything? Yeah, you have to make sure that when you plot all of the values, the units that you don't need cancel out, all right? And you'll be left with the unit that you need. All right, for number 6, for each chemical, write out a multi-part equality as shown in the example for water. Let's say you have 1 mole of water, then you just show the multi-part. So 1 mole of water has 2 mole of hydrogen atoms and 1 mole of oxygen atoms. So for CH3COOH, so 1 mole of this, you have how many? You have two moles of carbon, right? Two moles of carbon atoms, then 4 moles of hydrogen atoms, then 2 moles of oxygen atoms. Okay, you want to try letter B, C6H5NO2. Am I too fast? Yeah, that's right. 2 mole of oxygen. And for the next one, letter C, we have PT. What is PT? Okay, platinum. And then we have ammonia. How do you read this? Platinum ammonia chloride. Platinum 2. Ah, so this is different. So you have like ligands. This is for organic amine. So you don't use ammonia in this one. So you use amine from IUPAC name. So dichloro platinum, diamine dichloropplatinum 2. So that's the name of that. Okay, so 1. Okay. Yeah, that's right. Okay. And let's move on to the next one, number 7. Relating moles of atoms in a compound. Use answers from problem 6 for this and work the problems using factor label. How many moles of hydrogen are there? Okay, for letter A, we get the number of moles of hydrogen in 3.75 moles of water. It says number 6. Okay, so we start with the given number of moles, 3.75 moles of water. And we multiply this by the ratio of hydrogen to water. So times, how many moles of hydrogen in water? 2. So times 2 moles of hydrogen atoms per 1 mole of water molecule. Okay, what is 3.75 times 2? All right, so this is 7.5 moles hydrogen in 3.75 moles water. Okay, so let's move on to the next one, number 8. Where's that? Number 8. Oh no, there's still letter B. Letter B. 7B. Okay, 7B. How many moles of hydrogen in 25.0 grams water? So you convert grams to moles. Mole. So we start with 25.0 grams of water times 1 mole of okay. So we convert this first to mole water. How many, what is the molar mass of water? Because we're given here grams. Okay, 18 points. Okay, that one. So we can cancel out the grams water. Then we're left the moles. So that is 25.0 over 18. This is mole water. Then we convert to mole hydrogen. So we multiply by the fraction. No, the ratio. So 1 mole water is 2 moles hydrogen. Okay, let's calculate this. What is 25 divided by 18 times 2? Okay, so that's the answer for everything. Multiply by 2. 25 divide 18 times 2. So that is 2.78 moles hydrogen. So that's how to do it. Okay, for letter C, this is another one for letter C, because we're given the number of atoms. For letter C, how many hydrogen atoms in 25.0 grams water? All right, so we start with 25.0 grams water. Then we convert this to mole water first. So 1 mole water per, what's that, 18.02 grams. That's the molar mass of water. So the grams here cancel out. Then we have 25.0 over 18.0 mole of water. And then we multiply this by, ratio. Ratio of, what's this? 2 moles hydrogen per 1 mole water. Then the mole water cancels out, this one, because we are asked for the atoms. So this would become 25.0 over 18.0 times 2 moles hydrogen times Avogadro's number, 6.022 times 10 to the 23rd hydrogen atoms per 1 mole hydrogen. So the unit mole here cancels out. Then we will be left with hydrogen atoms. So what is that? 25 divided by 18 times 2 times 6.022 times 10 to the 23rd. What did you get? Okay, so 1.673 times 10 to the 24th hydrogen atoms. So you have to check your significant figures when you multiply and divide, so the least number. So maybe 1.67 only. And then for letter D, hey, what happened to the life? Okay, for letter C, how many moles of hydrogen in 6.75 moles C6H5NO2. Oh, that's a lot to calculate the molar mass. So we start with 6.75 mol C6H5NO2, and we multiply this by the mole ratio. How many hydrogen moles of hydrogen atoms are there? Okay, so 5 moles of hydrogen per 1 mole C6H5NO2. And that should be the answer. This cancels out. Yeah, you multiply 6.75 by 5. Yeah. Okay, so that is 33.75. Thank you. And you're welcome. Don't worry, I will help you.